Okay, today you're going to be learning about volumes. This is section 12.4 and 12.5 out of the book. If you need more help, you can go to the book and look at it. So volume formulas are much easier than total surface area. The volume of any geometric solid, which would be polyhedrons and ones that have circles included, is the amount of space that's on the inside. That's what a volume is. For a prism or a cylinder, the formula is volume equals big B times little h. The big B is one of the area formulas, just like they were in surface area. So you have to plug in a baby formula into here. For a pyramid or cone, it's 1/3 base times height. So that means that a pyramid or cone is exactly 1/3 the volume of whatever its sister prism or cylinder is, just 1/3 the size, because it goes to a point. The cube formula is volume equals S cubed, because volume is the three dimensions multiplied together. And for a sphere, it's 4/3 pi r cubed. So let's work a couple of these out very quickly, and we'll see what's going on. So first, identify the shape. This is a trapezoidal prism. It's got a trapezoid on the front and the back. If it helps, shade it. There's the front. So to work this one out, my formula is going to be volume equals base times height. In place of the base, we do the trapezoid formula. And notice there's two h's. The little h is part of the trapezoid, so the height of the trapezoid is 2.5. The big H is the height of the prism between the two bases, which is 4.2. So when I plug it in, I have 1/2 times the two bases added together. 5.6 plus 4.4 is exactly 10. Times the height of the little trapezoid, 2.5, times the height of the prism, which is 4.2. So the volume is equal to 1/2 of 10 is 5. 5 times 2.5 times 4.2 is 52.5 meters cubed. Remember, it's cubed because it's volume. So volume is always cubed. Let's look at this one. Now these are called right polyhedrons. This is called an oblique polyhedron. Oblique simply means it has a slant, so that the height will always be perpendicular to the base. So this time the height's 22. Since it's a cylinder, we use the same formula, but in place of B, we put pi r squared. So base times height, the base is a circle, so it's circle times height, pi r squared times h. So volume equals pi times the radius squared would be 49 times the height, which is 22. So 22 times 49 is 1,078 pi. Feet squared, cubed. Feet cubed because it's, again, volume. So you can do these other ones very simply. If it was me, I would probably shade the bases. Obviously, that's a triangular prism. Now, let's move on. So now we're going to this shape, which is a square pyramid. So we use the formula for a square pyramid. It's 1/3 base times height. So volume equals 1/3 base times height. What kind of base is it? It's a square, so really it's 1/3 s squared times h. In place of the base, it's a square, so we do that. So we get volume equals 1/3 times the side squared, 4 squared is 16, times the height, which is 2.4. Let me just plug it in. Since it's a third, I would go 16 times 2.4, then divide it by 3. And get 12.8 meters cubed. Any questions, you'll have to email me or come in the morning to get help if you have questions. Now, let's go to this one. This is working backwards. It's called solving for the radius. So this is an oblique cone because it doesn't go straight up like this. It goes like this, but we do have the height of 13. So when and the volume is 351 pi inches cubed, and they want us to solve for the radius. So first we write the formula down. Volume is equal to 1/3 base times height. And since it's a circle, it's going to be 1/3 pi r squared times height. Now we plug the numbers in. The volume is 351 pi. 1/3 pi r squared times 13. Now I'm going to rewrite it. 351 pi equals, on top it'd be 13 pi r squared. On the bottom, there's a 3. So now to get rid of this, I'm going to understand that if I divide it by pi, the pi's would cancel. Now I have to multiply by the reciprocal of 13/3. To multiply by the reciprocal of 13/3, I would take 351, multiply it times 3, then divide it by 13, and I get 81. And then take the square root of it, which would be 9. Okay, so it looked difficult, but actually it wasn't because we worked it out. Now you have to work these other problems out. Let's go to the back and see what's going on here. Okay, if you double all dimensions of a geometric solid, what happens to the volumes? Well, let's talk about this. If you double all dimensions, what happens to the perimeters? They always double. What happens to the areas? They'll be whatever happens squared, which is going to be, they're going to quadruple. What happens to the volumes? Well, if we follow the pattern, perimeters do the same thing. Areas are going to square and volumes are going to cube. So you would go 2 cubed. 2 times 2 times 2 is 8. So it'd be 8 times as great. So if you double all dimensions, then the volumes would be 8 times as great because 2 cubed is that. So when it's all dimensions, there's not much to work out. You're just basically taking whatever they do and you're cubing it. This one's different because you triple only the height. So I want you to work this one out like we did. Draw a line and work it out. Now, find the volume of the composite figures. Well, to find the volume of the composite, this would be the volume of this plus the volume of this, which would be 1/3 base times height for the top cone plus 1/3 base times height for the bottom cone. And then just plug the numbers in. This would be volume equals 1/3, because it's a pyramid. It's a square pyramid, so 1/3 base times height plus the cube, which is s cubed. So just plug numbers and work it. Okay, finish this note page front and back. Then do the second page attached to it. And when you're completed with everything, then you've finished your homework for the day. The scrambled answers will be on Blackboard, so you can check them. The scrambled answers are for everything in this whole packet. If you have any questions, again, email me or stop by in the morning. Goodbye.